We're going to do a little more AP review. Right now we're doing the 2010 AB-BC free response 2. It is the same question in both AB and BC, and it is a calculator question because it is number 1 or 2, and the most recent AP exams for the last over a decade have used 1 and 2 as calculator questions. So hopefully you have it in front of you. I'm going to go through the question. You are given a table. Just as a side note, when you're handed a table in a problem, you are probably going to be asked to use the table to estimate a rate of change, right? Meaning a slope or a derivative, right? And you're probably also going to be asked to use the table to estimate some sort of integration, right? Like a left-hand Riemann sum or right-hand Riemann sum or a trapezoidal approximation, right? So that's what we should expect when we see a table. So a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon, t equals 0, and 8 p.m., t equals 8. The number of entries in the box t hours after noon is modeled by a differentiable function e for 0 to 8. Values of e of t in hundreds of entries at various times t are shown in the table above. And the table gives us time at 0 hours, which is noon, 2 hours, which is 2 p.m., 5 hours, which is 5 p.m., 7 hours, which is 7 p.m., and the end, which is 8 p.m., so t is 8. Use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Show the computation that leads to your answers. So again, as I said when we first opened this, if you're handed a table, you're going to be asked to approximate the slope, and you're going to be asked to approximate the integral. So sure enough, A is asking us to approximate a rate of change. So if we're essentially being asked to approximate e prime of 6, right? The rate of change at 6. So that's really the change in e over the change in time, right? For lack of a better way to think about it. And since I want 6, I'm going to use 5 and 7. So I want e of 7, which is given in the table, minus e of 5, which is also given in the table, over 7 minus 5. And this is work that you want to show in order to get your credit. So when I do that, I end up getting 21 minus 13 all over 2. So my answer ends up being 4, and then remember, it's in hundreds of entries per hour, right? So 400 entries per hour, or however you want to write that. Sorry, hard to see that for a sec. There you go, 400 entries per hour. Again, just make sure that you don't call it just 4, right? So it's 100 entries per hour. And then let's go ahead and talk about our part B, okay? Part B says, shocking, exactly the other thing. Use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1 over 8, the integral from 0 to 8 of e of t dt. And then we're asked to interpret, using the correct units, interpret the meaning of that value. So let's go ahead and walk through B. So we're asked to approximate 1 over 8, the integral from 0 to 8 of e of t dt. So before you do that, it's worth knowing that this is the average value formula, right? So this is the average value of e of t in that 8 hours, right? In that 8-hour window from noon to 8 p.m. So that's the average value of the entry. So that's worth knowing. Now let's go ahead and do a trapezoidal sum. So remember, you can only use the shortcut for trapezoidal sums if your bases are all of equal width, and here they are not. So I'm basically going to treat each one like a separate trapezoid. So the first trapezoid, right, we use 1/2. The first trapezoid is from 0 to 2, so that's the height of this trapezoid, right? And I misspoke a second ago when I said the bases of the trapezoid. I meant the heights, which is the base on the x-axis, but not the base of what we refer to as a trapezoid. So 1/2 the height, which would be from 0 to 2, so it's a height of 2, and then the sum of the bases would be a 0 and a 4, because those are the two y values in the table. So that's the first trapezoid, right? Plus the next trapezoid is going to be 1/2. The height from 2 to 5 is a 3, and then the sum of the two bases would be the 4 plus the 13. Now I'm going to loop this down to the next row so that you can see it. 1/2, the height of the next one goes from 5 to 7, so that's a height of 2, and then the sum of the bases would be a 13 plus a 21, right? And then my fourth and final trapezoid, 1/2 the height goes from 7 to 8, so that's a height of 1, and then the sum of the bases is the 21 and the 23. You want to show this work. This is what the AP needs to see to indicate that they understand that you're doing a trapezoidal sum. But I did forget an important thing, because if you look, I did the trapezoidal sum, and the trapezoidal sum approximates this. But if you notice, what did I forget that the AP would totally get me on? I forgot that sitting in front of my trapezoidal sum is this lovely 1/8. So I'm going to make sure that I realize, oh crap, I screwed up. I'm going to put parentheses around the whole thing and put times 1/8, which is an okay fix on the AP. You want to make sure that you catch you made that mistake, but it's okay to not go back and rewrite all your work. So I didn't have the 1/8. I need to show them this work. It is a calculator section. You don't have to gut out the rest. You can type it in. You can do whatever you think is easiest. Either way, you're going to get that this 1/8, the integral from 0 to 8 of e of t dt, is approximately 10.687 or 8, depending on if you round or truncate. Now, because this is the average value of e of t, and e of t represents the entries, right? This is saying the average number of entries in hundreds, right, in the box between noon and 8 p.m. So this is the average number of entries in hundreds, right? So I'm going to make clear that it's in hundreds, right? In hundreds in the box from noon to 8 p.m. So again, we've talked about this in previous examples. It's important that we do reference this time frame, right? They did the integral from 0 to 8. They did that for a reason. We need to make sure we reference that in our answer. We need to make sure we use units. In this case, it's entries in hundreds, right? I believe the AP phrased it as hundreds of entries. I said entries in hundreds. That should be fine. All right, I'm going to erase A and B so that we have some room to do C and then D. All right. For C, at 8 p.m., volunteers begin to process the entries. They process the entries at a rate modeled by the function p, where p of t equals t cubed minus 30t squared plus 298t minus 976 in hundreds of entries per hour from 8 to 12, meaning from 8 p.m. to midnight. According to this model, how many entries had not yet been processed by midnight? So here's what we know, right? We know that if we want to know how many entries, so at 8 p.m., right? So at 8 p.m., there were 2,300, right? So 2,300, 100 entries, right? That's how many were in the box because that's on the table, right? So if we want to know how many entries are processed from 8 to midnight, right? So this is how many were sitting in the box, right? The number that are processed, since p of t is the rate at which they're processed, then the integral of p of t is the number processed, right? So from 8 p.m. to midnight, right? Because again, this is the rate that they're processed. If you want to find the number processed, you integrate the rate. So this is a thing you're going to make your calculator do, right? So you're going to integrate p of d dt, and you're going to get a value. It turns out that when you integrate, you get that this value is 16. So essentially, we're saying there were 23 entries in the box minus the 16 that were processed, right? So they were in the box. These were the ones that were processed, which means that there were 700 entries left unprocessed. Now, you could, because this is a polynomial, you could integrate p of t by hand. I would not. So just to go back and talk about how I got this 16, right? I would not integrate by hand. To be clear, what I would have done is in my y1, remember that p of t was t cubed minus 30t squared plus 298t minus 976. I would have put in my y1 x cubed minus 30x squared plus 298x minus 976. I would have done math 9, which is function integrate, y1, comma, with respect to x from 8 to 12, right? Interestingly enough, let's say you don't have a calculator, let's say you can't integrate this for some reason, the thing you want to communicate to the AP, right, so that's how I got the 16, but what you could have communicated to the AP, let's say you didn't have a calculator, was 23 minus the integral from 8 to 12 of p of t dt equals hundreds of unprocessed entries. So let's say that you find yourself in the boat where you're doing these questions and you blank and you completely forget, but then on the non-calculator section, you are allowed to come back to these and you have a revelation and realize that this is what you're supposed to do, but maybe it's too late and you can't use your calculator to integrate and it's something you can't integrate by hand. If that happens, do this setup, put the blank space, put the hundreds of entries per unprocessed entries, and call it a day. If you lose the 1 point for not having the numerical value, so be it. It's not a big deal. It's much worse if you just bail on the whole problem. Go back and fix it. All right, so let's do D. All right, last bit, part D. Okay, part D, according to the model from part C, at what time were the entries being processed the most quickly? Justify your answer. Okay, so as a reminder, P of T, right, which was T cubed minus 30 T squared, plus a 298 T minus 976, right? Okay, so P of T is the rate they are being processed, right? So that's the rate. If you want to know when they are being processed the most quickly, right? So if you hear processed fastest, essentially, processed the most quickly, that's a max for P of T, right? That's what they're asking. They're saying, when is there a max for P of T? So anytime you want extrema, right? So if you want extrema for P of T, you use a P prime of T sign chart. So there are a couple ways to handle this, right? My take is that the easiest option is to find P prime of T by hand. You're going to get 3T squared minus 60T plus a 298. Now you can do what you want here, but my guess is that this probably doesn't factor nice. So I know that there are certain kinds of critical points here, right? The critical points I have to worry about are, 1, when P prime equals 0. Well, I can use my calculator to find that. So I'm going to change my y1 to P prime, 3x squared minus 60x plus 298, and I'm going to second calc 0. And when I do that, I'm going to get 2 0 values. I'm going to get T is approximate. So again, this is calculator notation that you don't need to put on your AP, but you should know how to use your calculator, right? So I'm going to get 2 values. I'm going to get T is approximately 9.183503, and I'm going to get T is approximately 10.816497, right? The other kind of critical points are when P prime does not exist, but it's a polynomial, so that's not an issue. It's always going to exist. And then the third kind of critical point are my endpoints, and I believe that this problem does have endpoints. I believe that this problem has endpoints at 8 and 0, or I'm sorry, at 8 and 12, because this function, right, this guy right here, was only from 8 to 12. So I end up with 4 credible points. So the reason that that's worth noting is that essentially, oh, and I suppose if you wanted, you could have called this guy y2. That's probably the smarter play. So I'd put it in y2, and I would probably just turn off y1. The reason I say that is I'm about to use y1 again in a sec. So I would probably keep this guy as y1. So the reason that I'd say that's useful is that once you have these values, right, you can just go ahead and find the values of P of T at these spots, because these are all of your possible extrema. So all you need to know is that those are the only 4T that are possible, and then you can just plug into P of T with these in your calculator and see which of the 4 of them yields the largest answer. So if I do that, right, because I want the max for P of T, I go back up here, and if I plug those into my calculator, I'm going to get, there's a couple different ways to do this. One easy way is to just go to table and type in these values. Another way to do it is to graph. So if you called this guy Y1, right, and you graph it, you could then essentially press your trace, right? So if you press trace on your calculator, which is right there, if you press trace, right? If you press trace and then type in the x that you want, whichever of those 4 you want, you'll get a value out. So if you do that, you're going to find that when you plug in 8, you get a 0, which makes a ton of sense because at the beginning of this thing at 8 p.m., you couldn't have processed any entries because it just started. At the 9-point stuff, right, so 9.18, etc., right, 9.183, etc., you're going to get a value of 5.088662. When you trace and do the 10.816 and other stuff, you're going to get a 2.911338. And when you plug in the 12, you're going to get an 8. So when are the entries being processed the fastest? At t equals 12. So at t equals 12, P of T is at its max. Now, admittedly, that's a little bit frustrating. I don't know, maybe that's just me, but when I do all the work to find these zeros and then it turns out that those are not the extrema, that's a little bit frustrating, but it is what it is. So keep in mind that one of the points on this free response is for identifying these 4 candidates. So although neither of these panned out to be the max, just identifying them is important, and then being able to find out which one is the largest. Oh, and yeah, that's it.